Hi everyone, this will be the last video in the brief introduction to complex numbers. So far we went through the definition of a complex number, then we looked at some algebra of complex number. In particular, we looked at addition, subtraction, multiplication. When we did multiplication, we looked at the cyclical pattern that powers of I form, namely they go from I to -1 to -I to 1 and then back to I after every 4 repetition. Now the last thing that we need to learn is sort of giving a process to the observation made last time that since we can multiply to get a complex number, we should be able to divide to get a complex number. To do that, we introduce a new term which is going to be helpful, which is called the conjugate of a complex number. So what is this? This is basically what you do is you change the sign of the complex part. Okay, so for example, if z is 2 plus 3i, then the conjugate, which has its own notation, this notation is z but with a bar on top, would be 2 minus 3i. Similarly, if z were 1 minus i, then the conjugate, which is again written with a bar on top, would be 1 plus i. So notice it's the exact same numbers, exact same real part, but the complex part is switched. So the sign is switched. Positive becomes negative, negative becomes positive. Now if z were like real number, right, then that is 7 plus 0i, and 7 minus 0i still remains 7. So it would be the same. But if z were, say, purely complex, then what you would do is you would still switch the sign of the imaginary. So this would become negative 2i. Which means in general these are defined even for real numbers, right, or purely imaginary numbers. So the idea is just to switch the sign of the imaginary part. If it's positive, make it negative. If it's negative, you make it positive. For division, so why? Why do we use this? If you notice, if you look at z and z bar, right? So here 2 plus 3i and 2 minus 3i. This should kind of remind you of a plus b and a minus b, right? Which we know that if you multiply, you get a squared minus b squared. Which means that if we multiply z with its conjugate, 2 plus 3i, 2 minus 3i, these will still follow the same property. So this would be 2 squared minus 3i squared, which is 4 minus 9i squared, which is 4 minus 9 times negative 1, which is 4 plus 9, which is 13. What is that? That's a real number. So this is where we draw our motivation for how to define division. Yeah, is that we notice that if we take a complex number and we multiply by its conjugate, then we always end up with a real number. Why can I say it's always? Well, it's because it's always going to be a square minus b square, and the second square will give you an I square, which is negative 1. So there's going to be no trace of I left anywhere after this operation is done. So let's look at a division problem. Say 2 plus 3i over 1 plus 2i. So the goal equals, we should be able to write this as some number plus I times some number. That's the goal. So what we're going to do is we're going to multiply and divide by the conjugate of the denominator. Okay, so 2 plus 3i over 1 plus 2i, multiply, conjugate of the denominator is 1 minus 2i, and 1 minus 2i. Now, the bottom part is going to be I squared minus 2i squared, and the top part is going to be just another multiplication. So if you multiply each term, 2 times 1 plus 2 times negative 2i plus 3i times 1 minus 2i 3i divided by 1 minus 4i squared. So we get 2 minus 4i plus 3i minus 6i squared over 1 minus 4 times negative 1. So on the top I have 2 minus I minus 6 times negative 1 over 1 plus 4. 2 minus I plus 6 over 5, which then becomes 8 minus I over 5. And now I can use a fraction property that I can split this. And I can write this as 8 over 5 minus 1 over 5i. And now this is a complex number. Why? Because it's in this form. It's something plus I times some other thing. And in this complex number, the real part is 8 over 5, and the imaginary part is negative 1 over 5. So this means dividing these gives me this complex number. So the result would be written as 2 plus 3i over 1 plus 2i equals this whole thing, which is 8 over 5 minus 1 over 5i. Okay, so that would be division of complex numbers. So we use conjugate, the idea of conjugate, which should remind you of the idea of rationalization, right? So this is kind of like a realization or something, where you multiply by the conjugate in order to get the, you make the bottom part, the denominator, a real number, so that you can split it, and in the end you have a complex number. That's pretty much it for complex numbers and all the things that you need to know. And with that, you will be able to attempt the worksheet as well as do the homework. So that's it for complex numbers. Thank you.